一起啊，来着。好，我们等下再讨论老师哦，因为有人没有来，看一下上课的，先养，再养一下。Okay, let's revise derivative idea of derivative again, and then we have some quizzes on the tangent plane. Okay, so what's the idea of derivative again? Let's say derivative on calculus on one variable. 精深比较好，精深啊，我比较好啊，还好，要回答这个问题了。该怎么想 derivative？在 calculus of one variable 上面，嗯哼，它填进来的什么？填进来的什么？嗯，填进来的什么？啊，不是，原来的什么？gradient，OK，gradient。So 什么？为什么是 differentiate ex 过后是 ex？你应该要有一张，you should have a geometry in your mind. So you start with ex, right? You start with ex, the function ex, and then you look at the gradient at each point, okay? Or you can form the tangent line at each point, and you look at how these tangent line changes. Okay, when you change your time, when you change your x. Okay, so the gradient tells you what? If you look at the derivative of your f, it is still exponential function. Okay, so this is why the derivative is true. So the gradient also change like a exponential function. Okay, what else? For example, if you differentiate sine x, okay, you get cos x. What does it mean? So you start with sine x. Okay, you start with sine x, and then what? Then you also compute the gradient at each point. Okay, can you see cos or not when you see this gradient changes? Did you see the function cos? 有看到 cos function 的特征，有什么特征呢？那你看到这 gradient 哪个种？变痛。Okay, 周期性 periodic. Okay, where do you see the periodicity here? From 0 to 2 pi, what happened? The gradient repeat. The gradient repeats after 2 pi, right? Yeah, so for example, you look at 0, the point 0 and 2 pi, they have the same gradient. Not the same gradient line because it's line interpolated, but with the same gradient. Okay. And what else? Huh? You notice that where is this gradient non-zero at 0? Is it? Where is this 0? Where is it non-zero? So the gradient at 0 started with non-zero gradient, right? And then it decreases until it reaches 0 at where? Pi over 2. Good. Here is pi over 2. Here is 3 pi over 2. So that's why you see that your cos function looks like what? You start with 1, and then you go down to 0, and then go down to -1, and then go up. That's why here is pi over 2. Here is 3 pi over 2. So you see why here +1, here -1? Did you see the direction of your line? It's opposite. Okay, one is look like 1 equals to x, the other is y equals to -x. Okay, so it go to the other direction. You see it? Okay. Yeah, so that's why you go from positive to 0 and then negative because you're taking a function like y equals to -cx. Right? X. So you should think of derivatives starting using this way, because this will be useful for later courses. All right, so the quiz here is what is the tangent plane? So let's go up one dimension. What's the tangent plane of a plane at any point in the plane? Okay. 来问一下炳雄，这个题目问出来怎么样？再问。对对。啊。So in the tangent plane, playing the tangent plane, good. So when you talk about tangent plane, right, you need to start with a surface. So you need to ask yourself, what surface I'm looking at now? I'm looking at a plane now. And then simply pick a point. And then form the tangent plane. How to form tangent plane? Formula 是什么？我帮你开一个头先啊，有两个重要 ingredient 嘛，two ingredient 啊，讲看，OK，嗯哼，嗯哼，X Y X Y 讲 X Y，等，啊，就是那个 point，嗯哼，嗯哼，嗯哼，F Y 就过户了，哦，OK 呀，然后 X Y Y J Y 呢，OK。So are you implying that this f is a function or a scalar now? F function or scalar? But your x inside here can vary, right? So you should fix x and fy. Where should you fix these two values here? Where should you fix it? You see, can you see or not? This x is the same x. It's the same. X not, x not, y not. Okay, so this is the point you pick on your plane. So let's call our plane L, give it a name, and then let's call any point P here. Okay, and then let P to be this fixed point. Okay, good. So, yeah. I mean, this question sounds a little bit stupid. Very stupid. I mean, tangent plane is a plane. So what I'm trying to get here? Okay, what am I trying to get here? So well, let's look at example. So 这种题目不是你看到不是，你应该有一个 plane 的 example 先。你能够给出一个 plane 吗？这个 plane 给我们。嗯，OK, can we start with a plane? Okay, let's start with a plane. 你就画一个 plane 出来。Let's start with a plane. Okay, let's start with a plane. Maybe a plane like this. So you see, you need to get the formula for this plane, right? Okay, so how do you get the formula for the plane? So you need to know how to build a plane. So what's the ingredient of a plane? How do you need? Do you remember the general equation for what do you need? 他跟你讲一个平面，你需要什么资料？只要需要知道一个点跟一个 normal vector. You just need a point on that plane and a normal vector. So okay, so let's say our normal vector face this way. Facing this way, then maybe it could be could be okay, let's say this is 1 minus 1 1 1 minus 1 1. Okay, if I fix this normal vector, I can imagine how my plane faces. That's 1 minus 1 1. Next one is it 1 minus 1 1. So where is 1? X equals to 1 here. Okay, y equals to minus 1 here. And then you leave the vector up here. Okay, so this plane should be facing this way. So if I change the normal vector, then the plane will change. Okay? Everything perpendicular to this vector will form this plane. Okay, so every plane is decided by where the normal vector is. Okay, so once we fix this, can we find the formula here in this case? So, um, so, so let's say the origin is inside our plane. Okay, origin is here, 0 0 0. Guess to make life easy, we put origin here. So we have what? What's the plane equation then? What's the general form? A times x minus x naught plus b times y minus y naught plus c times z minus z naught equals to 0. Okay? But now we center at 0. Okay? So we can make life easy, make x naught, y naught, z naught 0. So what you need to do, you just need to plug the coefficient in. Okay, so these coefficient is exactly the normal vector. Okay, so what do you get? X minus y plus z equals to 0. Okay, but now you see here is 0, but we need a function. You know why is it a function now? You got how many variables here? 3 variables. 3 variables with one equation, meaning what? One of the variable will depend on the other. Correct or not? If you plug 2 values in, okay, if you substitute 2 variables here, you automatically get that. Okay, so that's why z will depend on the other 2 variables. Similarly, you can let x depend on that. y and z. Okay, but why we choose x and y? Why we choose x and y? Yeah, not really. It's the same actually. You pick any two is the same. But why do you pick xy over yz over xz? Why? I answer. What kind of convenience you want? Okay. Well, I mean, when you're picking x and y, meaning what? Your domain live in x and y. So meaning if I pick x and y, the domain is what? It's exactly the xy plane. Okay, so you treat xy plane as your domain. Do you remember I told you how to think about a function from two variable to one variable? You think of xy plane with height. Okay. So you start with xy plane and then you add the height in. It becomes a slanted plane. You start with the xy plane and then you give the height and then become a slanted plane. So in this case here, we will prefer to write the plane as fxy equals to y minus x. Okay, so now you got fxy here. Then you compute your fx and fy. Partial derivative. X and fy here. So if you do partial x, what do you get? What do you get? -1, good. Partial y. Good. So you don't need to evaluate point in this case because it's a constant function. No matter where you evaluate, it's the same. But can you notice something or not? You notice something? Okay, let's say I want to find the tangent plane at the 0, 0. What's the tangent plane? The tangent plane. What's the equation? Yeah, tell me do a formula. What do you get? Okay. Equal minus x plus y. But what is that? This is what you. Is it true or not? Last time when I say about tangent plane, what do? You need to zoom in around the origin, right? They should look the same. But you already started with a plane, so you should get the plane back. Okay, if you don't believe me, we try another point. Okay, we try another point. We try another point. So let's try some other point on this plane here. What point can we get? What point can we get? So let's try at. So let's write down what we have at 0, 0, 0. The tangent plane at 0, 0, 0. At tangent plane, at 0, 0, the tangent plane is x minus y plus z equal to. Okay, which is the plane itself. Okay, let's change the other point. For example, let's pick 1 and then 0. Can or not? Okay, can. And then -1. Okay, is this point sitting inside the plane or not? You know how to check whether this point sit inside the plane. So to sit inside the plane, you need to make sure the point satisfy the plane. So 1 minus 0 -1 should be 0. Okay, so this is the point living in the plane. Can you imagine where this point is? You can straight away guess on which side this point is. 1, 0, and -1. So it should be going down. Okay, so somewhere here. 1, 0, -1. All right. So what's the tangent plane here? Similarly, you sub into it. So z what? Z plus 1 equals to -1
times x minus 1 plus 1 times y minus 0. Okay, so you open it up. Again, what did you see? You get back the same thing.
Okay, even you do shifting, the shifting will cancel again. And such that you get back the same. Is it true? If you move to 0 minus 1, you still live on the plane, right? So when you zoom in further, you should get back your. Okay, because what does tangent plane do? It is a linearization. Okay, make your surface linear. Make it to a plane or a line. Okay, you go up there. Yeah, no. Okay, so a proposition is you can prove that the tangent plane of a plane at any point in the plane is the plane itself. Okay, it's the plane itself. Okay or not? Okay. Yeah. Any question? Oh, okay. Right. Okay. So next, okay, next I want to motivate this implicit function theorem. So remember that last time we did this implicit differentiation. We solved my brute force partial differential both sides. And then we use some sort of a chain rule or product rule. And then we get del z over del. Actually, there's a quicker way to compute this. If you can see it now, I'm not sure you can see it or not. Maybe you don't. But last time I mentioned about level surface. Get a level surface here. So remember that last time once we have these variables, the equation of involving few variables, we treat it as a level curve or level surface. But in this case here, there are three variables. So three variables killed by one equation, you should get a surface. Okay, so this is a level surface. There's one quick way to get this. So what's the one quick way here? Um, well, I mean, so what's the one quick way here? So let's try it. So let's try. Is it true or not? Oh, not. Wait, let me think. Is it true? Del z over del x. Oh, this one too many variable. I think cannot use this to show to you. Okay, sorry, I cannot use this to show to you. But maybe we try another example. Maybe try this one. Okay, let's say we use the old method to solve this. So what's the implicit differentiation here? So what I told you last time was if you get this equation, you just differentiate both sides with x. Okay, why? Because what we want to get dy over dx, but you can see that you cannot separate y from x here, right? Because there's a cube root there. So if you're gonna do it, then you will split this y into a few parts. So instead of doing that, we just simply differentiate both sides. Okay, and then what do? We actually treat y as a function of x. Okay, we think of y dependent on x here. Although we cannot split it, but somehow we know there's a relation between. Why? Do you remember just now I have how to see dependent variable? If I fix x, then you can somehow get your y already through this equation. Okay, you can solve for y. Well, I mean, to do this, what do you do? So you basically just differentiate all of them. And then this one, you use chain rule because y is dependent on x. And then on the other side, so there are two things depend on x, right? So you need to use
which what do you need to do? If your product of function depend on x, and then you want to differentiate it.有啊，听不到？OK，什么叫在左边啊？什么叫 dij 在左边？啊，右边怎样算？dy dx 这样，然后 x square，OK，就这样。哇，这个很简短，这个一次过做 product rule。product rule 要怎样做？还记得吗？rule 的 formula uv prime equals to what？ u prime v plus vu prime。说这边哪里 u 哪里 v？要再尝试一次。啊，加啊 ux 怎么讲吧，没有什么不好意思。6y(x) 加六什么？OK good。哎，知道为什么我们要用 product rule 吗？为什么？乘什么东西？六乘 y 你也不用，哎，6乘6你也不用用 product rule 啊，要用就很复杂。因为什么？不够，不够，两个嘛。这个 u 和 v 需要什么？他们两个都要 depend on y。Both u and v have to depend on y. Sorry, depend on x. Okay. So in this case here, we have the function x and the function y depend on x. So you need to use product rule. Okay. Okay. Now. So both u and v have to depend on x. So meaning well, so if you try to factorize your dy dx out, what do you get? 快可以算一下嘛。6y minus 3x squared over 3y squared minus 6少哪里 x 哪里 dy dx 少个 x 啊 dy dx 少个 x，OK， x 没有被动到哦，所以它还在 OK， 所以哪里要加多一个 x， 这里要加多一个 x，OK OK， 这样答案对不对？对，but we can simplify this right because we can factorize the 3 out, so 2y minus x squared over y squared minus x. Okay, good. But there's a quicker way to get this. Huh? So for example, if we treat the equation as a level surface, and so if we treat it as a level surface, what do we get here? So let's treat it as xy equals to 0, such that x cubed plus y cubed minus 3xy equals to 0. Okay. Then I claim that you can get this function straight away from fxy. My some partial derivative. Can you see? Can you guess the pattern? Get this fraction here from the fxy.
consider this. Okay, so if we treat this equation here as a level curve in this case, then I claim that you can get this answer here straight away from that fx1 through some partial derivative. What partial derivative we can pick? Maybe this one easier to see. They are already simplified. Through this. Can you guess the formula from here? So let me make precise statement here. So can you get numerator from this fxy or not? Can you get denominator from this fxy? I said. F3x. 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 So you partial differentiate f with x. So what do you get? You get 3x squared, and then you get minus 6y. Okay, so the difference is different by a sign here. Okay, so you get your numerator. How about denominator? Not. And how? So you partial differentiate with respect to y. Okay, so instead of you doing all these, right, this is the actual formula, okay, to get the answer here. And then this is the content of this theorem here. So if you have a level curve, okay, and then which define y implicitly as a function of x, then how to compute dy over dx? It is minus del f over del x over del f over del y. So I mean this line here, you might think this is nonsense here, but this is really important. Okay, otherwise, how do you compute dy over dx? You need to express y in terms of x, then you can compute. But how to compute it? Compute it from the f. Okay. Compute it from the f. So what do you see here? You see here the calculus of one variable is related to calculus of two variables. Okay, you use partial derivative to compute a derivative. But what's the geometric meaning here? What's the geometric meaning here? But what's the geometric meaning here? Okay, so let me bring the statement for you. So what's the geometric meaning here? What's the geometric meaning here? So the function in the theorem in full is this. So if you start with a level curve, okay, and then just pick any point. Okay, pick any point. X naught, Y naught, such that it live on the level curve. And actually you require fx and fy to be continuous. And obviously you need fy to be non-zero because you are dividing. Remember, every time you divide, you have to make sure the thing you divide is non-zero. Okay. And then this is the point here. Then y can be solved as a function of x near t0. That's all we need. You can write y in terms of x there. Just now, what's the problem with the x cube, x cube plus y cube equals to maybe 2xy, 6xy? What's the problem there? The problem there was I cannot write y in terms of x. But now this theorem says you can. Where can you do it? Only near the point that you want to look at. How near? Don't know. As near as you can. OK， 这个可能这个概念对你来说很抽象，到底多近？但是我要你记住一句话，就是近到你可以做这件事情。记这句话就好，以后你会知道这句话的意思。OK， 近到你可以做这件事情，好，OK。Such that The equation fx by x is equal to 0 that hold for sufficiently near x not y not. So I think sufficiently 这个词已经出现在蛮多你们的课上面。So sufficiently near meaning just say that around this x not y not, okay, you can still find points on the level curve. And still find point on the level. Then you can solve this dy dx.
Okay, so actually I need to draw you a picture. Okay, for example, this picture here. Let's look at this picture here.
Let's say this is a curve in this is a surface in fxy minus x squared minus y squared. Hey, does this function appear in your probability? Minus x squared minus y squared. Because Li Ming said she is going to teach you multiple calculation integration. That already had. But did you guys use it on this kind of function? Oh, that's an E here, sorry. Yeah.
There should be a E here. My E meshed into my surface already. That's the E here.
Huh? Go on. No. So integrate this in your probability column. Do you know how this function looks like? 有没？你们没有画没？快点看。Yeah. Normal distribution 是一条吧 but this one is two variable, so 它就 like 一圈。Then I draw here, then here. It's like so it's like bar shot. Why is it interesting? Did you guys compute this integral is equal to 0 pi over 2? Which one? Which is the answer? Pi square over 2, pi square over 2, 是吗? Something like that could integrate to a constant. Because why you would like this kind of thing? Because if it is equal to constant, then you can actually divide the constant to the function, then you will get a function that integrate to 1. Okay, so did she prove it to you why it's true? No, right. Okay, so later we will prove why it's true. And later we'll learn multiple integral. Then we will compute what's the integral, how to compute the integral. Actually, there's a trick to do it. All right. So, well, if you look at here, so just now we want to look for dy dx. What does it mean by dy dx?
What do you mean by dy dx here? And where is the level curve we are interested in actually? So let's draw this. So where's the level curve when this whole thing equals 0? Where's the level curve?
Level, right? So where's the height here? Where's the level here? Where's the height? Which axis represents the height here? Z. Good. Okay, so you look at the
when this function equals 0. Oh, this thing equals 0 a bit stupid, right? This thing won't equal 0 unless I move it down. So let's move it down. I move it down. Yeah, move it down. Shift it down. So let's shift it to, for example, let's shift it to -2. Let's just shift it down. So once you shift it down, then you can find this level curve here. 这样画到有点出入哈，因为我们的 height 是在0，所以把它摇下来。OK， 这样子。Try to keep the accuracy here.
all right. Then what do you do? Where's the dy dx? Can you imagine where's the dy dx in this case? The dy dx. dy dx 在哪里？你找的东西在哪里？你想啊？plane 啊？
在那个 xy plane 在哪里上面 ？Tangent line right？ Tangent line 在哪里？现在要画出来的。xy plane 这边全部都是咯，这边全部，所以我的 tangent line 发生在哪里？谁讲？ Ya kan? Exactly. So you look at how the tangent line on this circle here. Okay, can you convince yourself that I can write this circle using the function of y equal x? Can you convince yourself of that? 可以吗？圆圈好像不太行，对不对？但是记得我告诉你什么吗？我可以把圆圈拆成 upper circle 和 lower circle，所以这个就是 what I mean by sufficiently near。如果你是在 upper circle，我就看 upper circle 附近的点吧，我不要看到 lower circle 的点。If I want to find dy dx at the lower circle point, I don't want to include all the points up to the upper circle. I just look at the lower circle. This is what we mean by sufficiently near. Near such that you can write down the function. So upper circle, the sufficiently near only up to the moment where when y going from 0 to 1. And then lower circle, only when y going from 0 to -1. So this is where the sufficiently near happens. Sufficiently near, so you can go nearer. Okay, you can go nearer to the point inside your upper circle or lower circle. But the maximum you can go is either 0 to 1 when y equals to 0 to 1 or y equals to -1 to 0. You can go lower, go nearer. Okay. Yeah. Okay. So good. So let's quickly go through how to prove it. Let's quickly go through very fast one. Very easy proof. So basically, in this class, whenever I want to present you a proof, it should be what I wanted you to know, at least. Okay. So there are some proof I already skip all of them skip. But some of them I want to show you because there are some important concept and easy application of the definition. So I need to tell you how to put them together easily. Right. So if you want to prove it, so in the end, whenever you prove something, let me equate the proof for you. So proof have to equate to goal. Okay, you need to memorize. If whenever you ask me to prove something, I need to know goal first. Okay, you need to know your goal first. So our goal is this. dy over dx equals to this minus x over 1. So this is your goal. This is a formula that I want to prove. So how to start? So obviously you need to get relation between partial derivative and this derivative. Well, okay. So we start with assumption that's given. F of x, phi x is differentiable. There's only one definition I taught you. When is it differentiable? So when it is differentiable means what? I can use the tangent plane, okay, to compute the point in my surface. But remember or not, if the tangent plane far away from where I expand it, what happens? The distance between your surface and your tangent plane may be getting larger. Remember or not, we compute epsilon 1, epsilon 2 together. And when you go far away from where the point of tangency is, maybe the difference get larger. But what do? We add in the epsilon component. Then we use epsilon to control this difference here. So this is what I wrote here. So fx by x is equal to what? FAB, this is where we extend, where we draw the tangent plane. Plus what? Plus the contribution from the fx and fy. Okay, that two component. Plus what? Plus 2 epsilon 1 and epsilon 2. And then this epsilon 1 and epsilon 2 depend on what? Depend on how far you move away from AB. Okay, so that's why we take the difference. Okay. So maybe you wonder why there's a phi x here. Because the y component we can use x to control. It's like the circle we drew just now. If you want to get the y component, we can describe it using x. So become one variable.
And what? And then the nice thing is here. Did you ever ask why we look at fxy equals 0? And because if we consider fxy equals 0, a lot of things inside this equation go to 0. Okay, for example, the left-hand side go to 0. Why? Because this level curve are points inside my surface. Okay, so this level curve is a point inside the surface, which is 0, which is, it is a level curve, so equals 0. And then AB is also inside a level curve, so it is 0. So what you left with is this whole bunch of things with epsilon. So what do you left with? You only left with the term with partial derivative and epsilon guy. You're left with this 4 guy. So we need to use this 4 guy to assemble into this equation. Okay. So well, you already have 2 terms popping out already, fx and fy. Okay, we already have 2 terms popping out. How do you get dy dx? So this one will test you the understanding of dy dx. Okay, so let's group these 2 terms together first. Okay, let's group these 2 terms. So basically, what do? Basically, I move fx to the other side, and then this one. 放弃放弃，这个东西写错。但是应该说不一样，那个没有问题。我是说，这边有没有排错？感觉好像有点排错。看一下，大家看一下。你说这个跟这个应该要不一样。OK，I mean，我们到底少了什么？除一个哈，我现在也是觉得要除一个东西，除一个 FY 哈，我也是觉得少些了东西。OK，全部能看得到吗？这是普通的 algebra 搬来搬去吧，没有 differentiability 在里面。OK，这个号码搬来搬去吧，大家看一下会不会除？看一下大家 agree to 这个 answer 吗？Agree。很快的看就是把这个搬过去，把 A 搬过去，and then 全部人乘这种，是不是上面这一行啊？哪里不好？那哪个地方？觉得我们脏，哎喂，等下点有一点不赞成，我看一下，好像赞成，对，赞成，差点，对，agree。Okay, so basically you move epsilon 1, epsilon 2 to the other side. And then you just keep this fya by a by x on one side only. All the other guy move to the other side. Yeah, and then you divide by fy first, and then you add by a to the other side. Okay? Okay. Okay, so I claim you can see dy dx here. What is dy dx? What is dy dx? Yeah, maybe need to do one more step, huh? Oh, let's move this down. Probably we still need one more step to see. So phi x minus phi a over x minus a. A 对 which is equals to minus fx.
Okay, find A. This one you get epsilon. And then this one you get this solution. If you divide by x minus x. Okay, let's see. Let's see. Wait. Okay, so can you see here? We require this Fy at P now is non-zero. Okay, so that's why we can divide it like this. Okay, we can divide by this Fy. And then this, I think quite dangerous here, huh? Quite dangerous here. I mean, a bit dangerous here because we had x to 0, sorry, x to a, then what? This turned a bit dangerous. Okay, so well, before that, before we talk about the dangerous part, can you see that there's a dy dx happening here? Dy dx, change in y over change in. Oh, this part is the change in y over change in. So when you go take x, go to a, you can see that this fx, 5x minus 5a is the y part because we describe y in terms of x. Okay, and then x minus a is a different in x. And so if you take the limit, it is a dy dx. But you need to discuss why epsilon 1 and epsilon 2 go to 0. In this case, you just take it to 0. Actually, we need to discuss how we get rid of this. But it's not important in this case. But what is important for this proof here, I want you to see how these minus sign pops up. And how is this minus sign pop up here? 这个 minus sign 怎么 pops up？因为if you really just mnemonically like memorize this formula, right? I mean, you shouldn't have minus sign, right? You shouldn't have it because if you just simply treat it as a function, as a quotient, as a fraction multiplication, okay, you shouldn't see minus sign, right? But in this case, we have minus sign. Why do we have minus sign? Exactly where we stuck just now. Yeah, we need to move something to the other side. And then this minus sign pops up. Okay, so the purpose I want to show it to you is I want you to see where this minus sign. Does it make sense? Okay, so please don't forget the minus sign when you use this formula here. There's a minus sign. Any question so far? 问题吗？可以明白吗？好，我回去帮你解决一下这个 s minus a 的问题。好，现在我们先不用换。OK， 重点是 there's a minus sign 跑出来，当这个 epsilon 全部不见的时候。OK, please remember there's a minus sign here. If you just remember fraction, you won't remember this minus. 有问题吗？没问题吗？没问题，我们等一下就要跳掉这个 implicit function theorem 我们下一个会进directional derivative. So in next hour, we are not just looking at direction in x, y anymore. We can actually look at every direction. Right? This is called directional derivative. Okay, because in two-dimensional, you have how many directions? You have like circle tons of direction. 360度你都会有走。Okay, not just x and y. 我也可以这样子走过去。
我不一定要这样直走在同人走，不用啊，这个很傻觉得，对不对？我们可以直接走，直接往前，去 any direction。OK，later we'll learn direction 那个。OK，有问题吗？有问题吗？我这个算应该我 OK 吧？刚才我说给你一个重点就是你要记得 this minus 3点。OK，right。Okay, if there's no question, let's take a break until 10:10.
X 就是那个
嗯
，X
square 减 y square 啊，
它不能减2然后到2，因为它的厚度只能从2除1。
哦，太多了，你说切太多了，
对，
你说切太多了，OK OK，切0.5就够了，0.5够了，0.5够，OK，切0.5。哎，你刚才可以直接说，哎，没有，他说他高度没有到1是吗？高度到1罢了。就1吧，因为 s square y square 0的话就是1就是0嘛，1和0是1对不对？对啊，最高点是1对不对？
但是最低的照标。
哦，最低点到最低点对，最低点到不了0，对对，I mean 对，变到不了0，对，就到不了0，就是因为我只要把它移下去的原因，只是说移太多了，连那个最高点也被移下去了，对，其实要的话我就 scale 它也可以，就是在前面乘个3也可以。 Thank you, Humpo, for pointing out this shifting just now.
Because the highest point of e to the x squared minus x squared minus y squared happened at the origin, which is 1. Yeah, so if you move this point by -2, you will move away from the xy plane because you will get -1 for the highest point. So instead of doing that, you can just move maybe 0.5. Okay? Or you can really scale it. Then you can scale this graph maybe by 3, for example. Then you can move by -2. Yeah, otherwise, the maximum point of e to the minus x squared plus y squared, you can see that it's actually, I mean, see from this graph for now. Later, we will really learn how to find maximum minimum point for two function of two. Okay, but in this case here, you can see that this is a point at the origin. So the origin is 1. Okay, if you move by -2, you will move away from the xy. Okay, yeah.
Okay, continue. Right, continue. I mean, this one later. So I'll talk about directional derivative now. So well, I mean, we have learned 2 direction at least. Okay, we have learned 2 direction for partial derivative. So one direction was fx, and the other direction was fy. So if you remember, what's the limit definition of this? You just look at the change in x direction, okay, and then you keep y fixed. Okay. So well, I mean, it turns out there's a compact way of writing this. Okay, so there's a compact way of writing this. You can write it in a linear algebra way. Okay, because R2 is really a vector space here. Okay, so we can write it more compactly, for example, using the vector notation. Okay, so they are really equivalent here. Okay, so this is this is actually the idea you have seen before, like why in high school sometimes you write a point as let's give two variable. So maybe you write this point as 1, 2. Sometimes you see it as a vector. Okay, so they are equivalent actually. I give you a vector. This vector has to start from the origin. So if I give you a vector starting with origin, it's the same as I give you that point where the vector is. That is equivalent. It's equivalent. So what's this vector here? If I tell you that this point is 1, 2, can you figure out what's the vector here? That start from origin, go to this point. Do you know? What is it? And what's this vector here? What's the vector that go from origin and then end at the point 1, 2? Huh? I don't. What's this vector? Okay, yeah, sure. So you can write it as 1, 2, or I plus 2j. Okay, so what's this I? What's this j here? This I is exactly your standard basis. Your standard basis. How you get this 1, 2 here? You can realize it as what? Addition of two vector, right? So what's the two vector you can add here? You can add the horizontal and the vertical vector such that this vector going from 0 to 1, 2 is a resultant vector. But how do you get the horizontal component and vertical component? Exactly, this is the vertical and horizontal component for your. So that's why this is a 1. Okay, so there's a 1-to-1 correspondent here. So through this, we can go to different direction. Why different direction? Because we can replace H0 with different vector inside of vector space, and not just a vector input type. And maybe we can do H1, change it in different direction. Does that make sense? Okay, so we can replace this change of a vector here to the other direction. So for example, we will define that. Let's define it. So definition for any unit vector u. Okay, so let's say this is u2. Okay, the directional derivative. So meaning this derivative come with direction, not just x and y. We consider and all sort of other direction at p in the direction of u. So you need to tell me two important things when you want to talk about directional derivative. You need to tell me where you stand at, and then where you look at. Okay, where you stand, okay, at p. Direction, in which direction you look at, in the u direction, is what? So you differentiate your function with respect to the direction u is what? Is the limit, okay, limit of, let's write it as a vector form for easier for you to see. So p1, p2 plus changes in that direction, okay, minus fp is the same. So minus f p1, p2 over h. Too long, this one. Okay or not? Okay, so let's test you. If my direction is x, what's this u1, u2? If my direction is x, what's my u1, u2? Huh? 1, 0. So if my direction is 1, what's my u1, u2? 0, 0, 1.
So this direction derivative include the partial derivative we learned before. Okay, so this is more general. Okay, so this is more general. So don't be don't be shocked when you see linear algebra here, because actually vector calculus is a combination of calculus and linear algebra, because we put calculus in a vector space in higher dimension. So we need to use linear algebra language. Okay. So it is this if the limit exists. Okay, if the limit. Okay, good. So I mean geometrically, what is this? So last time we talked about when we talk about fx, fy, we say that it is the tangent line. Okay, when you take, so for fx, where is the gradient live in? Where's the tangent line for fx live? Where's the gradient? You take zx plane and then intersect your surface, and then you look at what's the changes along that line. Okay? But if you change the direction u, meaning you start with any u direction inside your domain, and then you look at the plane that's spanned by this direction here. Okay, and then this plane will intersect your surface. So last time we discussed, right? If you take two surfaces intersect together, what do you get? Your intersection will go down a dimension. So maybe you get a line or you get a dot. Okay, so if you get a line here, this directional derivative tells you the gradient of this line. Okay, does it make sense? 有问题吗？有问题？有问题吗？医生？Okay, yeah. So I mean, 哎，你们有没有问一个问题？你们应该要问问题啊。那么要 unique vector，我只要方向 vector 就好啊，这么你调我的长度，所以你们没有问这个问题啊。所以我长度一定要1哦，反正我只是看方向吧。可以是可以，诶，不清楚，我没有看到这个方便，至少之后可能会方便了啊。What sort of projection? I don't know 我没有看到，我不知道。但是等一下会让你看到，是我们在做一些计算的时候，我们不要让这些东西被它的长度影响。我只要记得它方向吧，我不要被它的长度影响。等一下我们会算一个东西，它长度会跑出来，然后我们不要被这个长度影响。Okay, we don't want to be affected by the length of this unit vector, this direction vector, because what? Because if the length is 1, anything times 1 will be itself. Okay, if your length is 0.5, then you will half the other number if you multiply together. So later, this length will come up when we do some computation, and we don't want to be affected by this length here. Okay, later I will show you. Okay, so 每一个字啊，你们其实都要问啊，都有原因的，为什么我们要放这些字进去 ？OK， 都有原因。So be sensitive to these conditions. Okay, let's prove one more stuff, and then we will do a calculation. Similarly 啊，又来一个同样的套路了。我告诉你哪一个 definition。通常我们是不会用这种 limit definition 去解的东西啊。意思说什么？来，谁能解释一下这个套路？下一步我们猜一下我们要做。对，我们要有一个 theorem， 而且这个 theorem 要怎样？猜。这 theorem 要告诉你怎样算这个东西。但问题是又不可以用 definition 算，要怎么算呢？用之前会算的东西。So let's see how we relate this random directional derivative to what
we have learned before. So the theorem is if f is a differentiable function in x and y, then f has a directional derivative. So has means what? You can find it. How to find it? Oh, actually you use the partial derivative with respect to what you know before. But how do you do the combination here? You take fx, xy multiplied by a. Where is this a come from? This is exactly the direction of your unit vector in x coordinate. And then plus fy of xy times the y coordinate of your y. So it's a linear combination. So meaning what? This du actually is a linear combination of a xy coordinate. And the coefficient is what? It's just the partial derivative with respect to x and y. 有道理吗？你觉得？有道理吗？ So fx is a change in x. Y fy is a change in y. But now I ask you another question. Maybe I want direction x plus y. Then what does this formula tell you? You just take your x plus y and then multiply by the coefficient. 真的很 linear algebra 在这里。Okay. But how to prove it? Actually, this proof is not too hard. So let's quickly show it. I mean, this proof is, well, I mean, you can look at this proof and then try and study it. I would say, 不然你跟我讲一下你的第一印象是什么？你读不用读懂了，你读啊，跟我讲一下你的第一印象，我再 interpret 给你听。那给你2分钟、1分钟读一下，不一定要读懂吧？你的第一印象是什么？因为每次在家读书嘛，我没有在你旁边嘛，你要读给我看。如果有人读完了，可以分享一下。不一定要读懂它，但是你就读了，你是什么？一元函数。The main function of one variable. Okay. Okay. Sure. 还有吗？
那个 A 跟 B 可以写成tan西塔跟 sin 西塔。就我看，
然后呢？往你走这边了，你说这边了。好 ，OK，然后就怎样？写到那边就怎样？中间有用这个计算吗？中间没有啊。proof 里面没有用到这个东西，这是后面等下我们算东西的时候有的。其他的呢？对这个 proof 什么概念？因为你第一个要问的是中我要 define 那个 GH。What not 什么？你讲吗？Not that. Oh, okay. Sure, I mean, well, yeah, right. So 它这个 GH 是拿来做什么？其实 GH 是做后面的计算。如果你 GH 不知道，你还是可以做后面的计算。你懂什么意思吗？所以他做什么要叫一个 GH 呢？方便吧？不然很长，你知道吗？G prime 的这个东西这么长，你怎么教它？你要念整个东西了。如果我 let GH 等于那个，then 我只要讲它的 derivative 是什么就好了。你再讲 limit of blah 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 什么，所以它只是一个名字吧。其实 define 这个东西没有特别，已经存在了，对不？它只是给它一个名字吧。OK， 所以你有时候你读数学啊，有时候啊，你要知道有些东西是已经存在的，它只是给它一个名字，因为很长啊，你不觉得很长吗？假设我这篇里面没有 G 在里面，你要把全部的 G 写成那些东西，是不是很长啊？所以它就缩短这个一直出现的东西。 就说analysis proof 是这样，analysis proof 很多都是这样啊，因为我觉得这个是有一个好处啊，好处就是你的 presentation 会变清洁一点，不然的话你想想看啊，你把全部 G 去掉 ，OK 你就放回它应该要的样子，就剩它左边那个，你就做同样计算，也是拿到你要做的东西，懂我讲什么吗？有没有人懂我在讲什么？For example 啊，for example 就不用看这个，就 I mean 不要看这个，不要看这个，反正这个也是这个计算，and then 这个 G H 你就要把这个搬下来了。对，所以你就看到很多个这样的 limit 啊，f 加东加东加西加，就感觉很乱，对吧？OK 吗？OK，说取名字有一个方便啊，你会知道哪些东西一直出现，然后哪些东西是你算的东西，okay，哪些东西是已经有了。But well, I mean, I can present you another proof, easier proof. So let's present you another proof. So okay, let's present you another proof. So what do you want to show? 每一次你写 proof 啊，你一定要写你要做做模先，so that you won't forget where you want to go. So what's the directional derivative? It is a weight. Okay, weight on the x direction and y direction depend on your u direction. So 我要 prove 这个东西。说这个东西怎样来哈？这个东西怎样来？So I mean prove 这种等于的东西是很不是讲简单，就是说你知道你要做什么。prove 等于的东西应该怎样做啊？通常你可以 start with 左边，你可以 start with 右边，but 你一定要 end with 你要的东西。OK，let's say like this。所以中间是什么？你要补进去。其实你们的书已经很好读啊，现在为什么？因为他跟你讲答案了，左边等于右边。In real life 啊，research 啊，只有左边嘛，右边你去找，明白吗？所以这个答案已经给你了哦，所以他只要你 work out 了，只要 work out 吧。So 怎么 work out 呢？Obviously, we need to start with definition. OK， 一定要从 definition 开始的。So DUF 的 definition 是什么？刚才我们讲了 ，is a slight change in A direction, mean U direction in X coordinate, and also slight change in Y coordinate of U direction. Okay. So what is this AB? Let's name it first. So my direction vector is AB. 我一直换 notation， 你们会乱吗？因为有时候又这样子，有时候又 row vector， 有时候又会乱。这些全部你们要equate起来。well， 你如果看很多 calculus 课本啊，通常是 row vector， 但是如果你用 linear algebra 课本，它就是 column vector。在这个班的话，两个都可以。Actually， 我 prefer 是 column， 因为我是 algebra 的。But it's okay, both is okay. Right. So 怎么去到后面这里呢？怎么去到后面这里？This is the question. 有一个条件我们没有用 ，f has to be differentiable. OK, f has to be differentiable. So f differentiable 的意思是什么 ？f differentiable 的意思，记得那个 epsilon 1、epsilon 2，不记得去找一下 definition differentiable 的 differentiable 的定义是什么？还记得吗？
Oh, that one is theorem, right? That one is theorem, right? Theorem. If x, f, and fy continuous, and then you can prove that f is differentiable. That one is theorem. How about definition?
A linearization 有关系，和 tangent plane 有关系。
和 linearization 和 tangent plane 有关系。
知道吗？你知道吗？
这我要找一找。哎，你们有找到吗？建彤知道吗？不知道，为什么不找一找？参考一下。不知道要找一找诶。找到了看不懂，然后我们解释。differentiability 是什么？这串东西是什么意思？What happens before epsilon here? This is the tangent plane. And so this is the tangent plane. This is the point on tangent plane. So meaning what? The difference between. Okay, so okay, how to read this 啊？你要形象化去读这个 definition 啊，不然的话你看字是看到昏的。你要形象化去看这个字，看这个 definition。怎么形象化去看呢？稍微的 AB。OK， 稍微 AB。From this surface 啊，我知道它的 height， 我知道它高度它在哪里。现在我的问题是，我要知道这个点附近的高度跟这个高度的差别在哪里。So what do I do here? So what do I do? So on AB, I have this height. I can form a tangent plane. Tangent plane. And then what? Okay. 未来，我们有一个图了。So on this surface, okay, let's say this is an AB point. I form a tangent plane. I form a tangent plane. And then 我要问的问题是 if I move this AB away, you can see that this height will change. Now the question is, how does this height change according to this tangent plane? You can see that if I move really far away from this AB point, the difference will become large. In other words, what? If I move closer to this AB point, the distance will become smaller and smaller. Okay? If this happens, then the function is differentiable at that point. 意思说这个 surface 在靠近这个 AB point 的时候是可以被这个 tangent plane 取代的，对吗？可以被取代的。哎，还记得吗？那天我说你那个 Google Earth， 在外面看是圆圈，它是站到里面来这个 tangent， 所以我们的 Earth 是 differentiable。我们 Earth 是 differentiable。真的，没有，真的，因为 general relativity 就发生在 differential geometry 上面。对，相对论就发生在这个微分几何上面 ，differential geometry。OK， 我们2是 differentiable 的。Right， so how to use this formula here? Okay, where's the formula? Yeah, where's to use the formula here? Okay, we're gonna use this formula. 我们把它 screenshot 过来。Let's screenshot it. OK， 可以看到这个他们的什么？相似数嘛，不用这个 formula。If f is differentiable, I can replace fx plus ha y plus hb with the right hand side. Replace it. 就把它变成右手边 ，because f is differentiable。OK， so 这边我就写 since f is differentiable， I can replace the first term here with this sum. So in our case is x y plus fx xy delta x. So in this case here, what's the delta x? You know? In our case, what's the delta x? It's h a. Okay, it's h a. And then fya xy of hb. And then plus epsilon 1 of ha plus epsilon 2 of hb. Everything over h. Okay, good. 哎，有少东西吗？少了东西不是？我们还有一个减 fxy。所以你看有一个 magic 出现了，看到 magic 吗 ？magic 来了。Do you see magic? Where's the magic? You see magic? There's a magic here. Not magic. Yeah, so fxy cancelled. This is the only term that's without h inside the numerator, but it's somehow cancelled. And then everything divided by h, so h can be simplified. Okay, so 这些除有原因的啊，它是会被除掉的。And then what do you left with 啊？You left with 我切掉一半很重要的东西。If the del x del y go to 0, epsilon 2 goes to 0. So this h here represents the changes. So if you take the changes go to 0, meaning these two terms also have to go to 0. What do you left with? You exactly left with fx xy a plus fy xy. Okay, so this is what we want. Okay or not? So we just, what do we use here? We just use three things. Definition of directional derivative, definition of differentiability. Okay, 两个吧 just these two. Okay, two things. Then we get this proof. Understand? Okay. Okay, so this one go to 0 when we take it. Right, so let's do some computation here. Okay, let's go down do some computation. Look at. Let's see which one we want to do. Okay, let's do this one first. So we start with a surface s cubed minus 3xy plus 4y squared. Why is the surface? Because this is a function from R2 to R. It tells you every point, okay, what height correspond to. So if you graph this f here, it is a graph in R3. So in R3, so this is the graph for you already. This is the surface. And then what do? You want to look at the directional derivative. In which direction? In the direction of you jump. Oh, you jump. So he didn't give you the, the exact U1, U2. What did it tell you? 告诉你什么 instead? Instead, what it tells you? Instead it tells you the relation between this unit vector and the positive x-axis. Okay, so where is it? Which quadrant it lies? Making an angle of pi over 6 with positive x-axis. Pi over 6 is 几度? Less than pi over 2. So which is living in quadrant, first quadrant. Okay, so it should be somewhere here. Pi over 6. Okay, so if I give you the polar coordinate, right? Is it I'm giving a polar coordinate? Because I know that it's already unit vector. And then this is pi over 6. So you should work out the xy. Correct or not? Okay, so this is what you have tested last time. So u equals to cos pi over 6 and sine pi over 6. R cos theta, R sine theta.
but the radius here is 1 because we want the unit. Okay, so this is our unit vector. And then you look at the plane, okay, that's spanned by this unit vector here. Actually, not true, not plane spanned by unit vector. Because plane, you need how many vectors to span? Plane is 2-dimensional, so you need 2-dimensional dimensional vector to span this plane. Well, what's the 2 vector that span this plane? Plane that contain the vector u. What's the other vector? How to get the other vector? Is it clear how to get it?有没有想法？linear algebra 问 Azmi 一下。我要找一个 plane that contain 一个 vector，怎样去找另外一个 vector that 可以 span 这个 plane 的 ？Yes, exactly. 你要 orthogonal project 啊？你要 orthogonal project。branch me， 对，怎样 branch me 法
？Well, I mean, if you do the grudge me stuff, right? Either you will found this first, or either you found this one. Okay, so if you found, let's say this one UVW. If you found W, then this is what you want.
But sometimes you will find, yeah.
应该三个不一样名字 UVW. So
if you found V, then V and U will span this plane. But let's say if you just found W, then how can you find V? You just yes. Well, I mean, find W is also enough to find this plane here because this is a normal vector to this plane. But if you want to see which 2 vectors that span this plane, you need U and V because W is not inside it. Exactly. So you need to use branch reform. Okay, so either you get this W first or either you get V. Then if you get V, then this is the 2 vector that span this plane. If you get W, W is the normal vector to this, where you can get formula for this thing. Okay, so either 2 of them is very good vector here. Okay, cool. So let's compute du f1. So how to compute du f1? So let's compute du fx first. What's the formula? Okay, I proved so long already, so you need to know what's the main point I prove it. So what's the thing that left over, okay, after you take the limit? What's the thing that left over? Fx of xy times a. So in this case here, let's name it u1, u2, okay, to be consistent here. So u1 plus fy xy u2. Okay. Okay, why we can do this? Because our f is differentiable. Okay, why is our f differentiable? Because fx and fy exist and then continuous. So we compute fx and fy. Is it exist? Is it continuous or not? Very easy computation, right? So what do we get? 3x squared minus 3y. Okay, and then time u. U is what? Cosine over 6 plus fy is what? Minus 3x plus 8y times sine over 6. Okay, so you can see that these 2 are partial derivative exist and continuous. So f is differentiable. So if f is differentiable, this calculation will work. Okay. 所以你看可能我知道为什么我们大学不要教这样子的考科，因为你看我们的做法是 assume 全部都有了，就是assume 全部都有了才做。其实如果按照逻辑来讲，是我们要知道这两个先，知道这两个了 ，then as is continuous, then f 才 differentiable。f differentiable 了过后，我们才有那个 proof， 对不对？我们 proof 里面需要 differentiability，yeah。 所以为什么有时候我们一直训练 calculation 的时候会训练错学生，就是因为他运用的逻辑跟他来的逻辑是相反，懂吗？你要这么做，其实你要知道这两个 exist 的 combination， 但是我们somehow已经assume 它有些，哦，真的有，有了，我们就整个就过吧，明白吗？做算的逻辑跟验证的逻辑是反的，听懂讲吗？川语听不懂要问，我重复一次。对，算的逻辑跟验证的逻辑是相反的。说你们就是因为你们是在数学系嘛，你们要清楚知道你自己在算什么，不是在算嘛。但是这样子写又没有错，因为刚才所说的条件都符合。但是我们检查条件的时候，当然是不可以先写这些东西的。OK， 但是就
OK，right，好，这个是这个。So now you want to compute at which point? 1, 2. Okay, so we need to evaluate xy at 1, 2. Okay, so you just evaluate it, and you should get 13 minus 3 square root 3 over 2. Okay. Maybe we go a bit over time, and then we will spend the last hour for exam. Let me go further a bit. Okay, so, well, I mean, let's go back to where? Let's go back to this formula here. Okay, actually, there's a one compact way to write this formula. There's one compact way to write this formula here. 想想看在你的 imagine your linear algebra. How to, I mean, is this operation familiar to you or not? You are adding up some product. So which two vector you dot together such that you can get this sum here? So you can group your partial derivative together. Dot with the unit vector. Verify 一下，对吗？ Can you verify it? 上面乘上面加下面乘上面。This is dot product, right? So we will have a special name for this vector here, which is what we call the gradient of a function. Okay, this is called a gradient of the function. Okay, in one variable 在 one variable 里面 gradient slope 全部都是一样东西。But in higher dimension, gradient and slope is different. Slope is a number, but this is what we call a gradient vector. What's the gradient vector? You simply collect all the partial derivatives in the main direction. In this case, it's xy. So if you go to higher dimension, you go x, y, z, and then and then it's the basis of your vector space. So we'll define the gradient of f to be del f del x and del f del y. So here there's two presentation here. So here is a row vector. And then this one is a linear combination of standard basis. They use IJK here, standard basis. But this is really the E1, E2 inside your linear algebra. And I mean, in my class, you can use a column vector. Yeah, I really want you to equate it with linear. It's no different. Okay, so we make it a compact notation here. Del f dot with u. Okay, we call this a gradient nebula f. Sorry, not del f. Nebula. Okay, nebula f. Inverted delta nebula f. Any question? 还是一样东西啊，我是取新名字吧。Okay, just a new name. Same thing. Let's see. I will show you what is the use of this gradient vector like soon. Okay. And then I will address the unit vector issue also together. So let's do exercise. Okay, do this exercise. Find the derivative of this surface at a point 2 minus 1. Okay, in this direction. So let's use the dot product way to compute it. So let's use the dot product way to compute it. So this direction, it gives you 2i plus 5i. Is this a unit vector? A unit vector, man. No. Why? How do you compute? Square root 2 square plus 5 square. So this norm is what? 4, 25, 29, square root 29. Okay. But can you make it into a unit vector? Can you make a unit vector or not? Divided by square root 29. You know why v over norm of v is a unit vector?有 proof 过？有 proof 过？但是有看过真正的 I mean 就是真的去算嘛 I mean for example in this case what happened 这是 proof 过但是你知道例子吗 and for example compute this one is a norm one 你会看到很乱有很多什么 square root 在里面其实这个 square root 就是帮助你的东西来的看得到他怎样帮你吗他是天使来的你以为他是魔鬼但是他是天使看到为什么他是天使吗你尝试一下去算这个东西那个 denominator 是天使来的，你觉得第一次眼看它很乱，它是天使来的，看得出为什么它是天使吗？为什么它是天使？怎么算？会写，来算 ，no。OK，第一个它是什么 ？OK，我们直接 square 它了，所以就4/29加19，答案是1 ，square root 1是1，所以你就拿到 unit vector，可以吗？懂什么意思吗？What you divided with is the total. That is the norm, is the normal norm. So this 29 will help you cancel out the norm that you get. Okay. Okay, so new tools here. So we understand this directional derivative using gradient gradient function here times the dot product with unit vector. Actually 这个东西比较容易记哦。刚才you need to use linear combination. 现在这一种乘法 is a kind of product. Okay, and this is a dot product. Dot product 给你什么东西啊 ？Dot product 你知道从哪里去哪里吗 ？Where's the domain? Where's the codomain? Dot product. R2 to R. Yeah. R2 to R. So dot product is a function from R2 to R. Okay. It's a function from R2 to R. So let's write it down. So what's the del F del X here? 我们还记得我们的 F 吗 ？Okay. So with respect to X, what do you get? 2x y cubed. And then with respect to y, differential with respect to y, you get 3y squared x squared minus 4. And then dot with this looks horrible vector here. Well, I mean, what do you get in the end? You get also a kind of horrible thing here. Okay, not very nice looking. But it's okay. Okay. Hey, but
哎，问题来了，又来了问题啊。So what do you see here? This is a R2 to R. And all dot product after dot product is a R2 to R. Good. So dot product here, where is the R2? One of them you take from delta gradient, and one of them you take from the hey, sorry 那也是 R2 to R， 应该是 R2 cross R2 to R。OK， 两个 R2 because you take two vector dot and two copies of R2 and then two R。OK， 比我们之前做的 two variable 还复杂一点。OK，two variable 只是 R 乘 R 去 R， 这是 R2 乘 R2 去。OK，Well， 如果是去 R， 为什么这边还有 XY 哦？它是一个 function，good。Exactly， 它是一个 function。OK，
so meaning what? If I evaluate at one point, 它才是一个 R. Okay, 它才是一个 R. So if I evaluate at one point, only then it become a real number. 我们需要 evaluate 吗？需要哦。So there's a point. Okay, so let's evaluate at 2 minus 1 here. This one. So we'll get 32 over square root 10. Only then this is called the slope.
This is only then we call the slope of the tangent line.
Okay. 还记得怎样拿到这个 tangent line 吗？
You need to look at the direction, the plane that contains this direction, and then this plane will intersect your surface, and then you will get a curve, and then that's the slope of this tangent line. Why I don't use gradient? I don't want you to confuse with this gradient vector here, because now we involve few dimension already. So I will try to keep the gradient name for this gradient vector, and then we will keep slope for this gradient in one variable, in one dimension. Okay. In one dimension is the same, 就一个号码 but in higher dimension, gradient vector here is a vector. 会符合吗？会符合吗？会符合预期吗？因为为什么哈 ？If you start with a line, your gradient, your tangent is a tangent line, one dimension. But if you start with a surface, you're not talking about tangent line, or you're talking about tangent plane. Tangent plane is R2. So your gradient lives in R2. So this is the gradient vector. Okay, your gradient lives in R2. Okay, but if you evaluate this dot product here, you get a slope. 又跑回 one dimensional 的东西。Okay， 这个 one dimensional 怎样出现在 surface 上面 ？You take the plane with direction u, the unit vector u, and then you intersect with your surface. You get a line. It's a one dimensional. If you go back to one dimensional case, you can talk about tangent line on that curve. Then what's the gradient there? What's the slope there? Is this evaluation here. 明白吗？有问题吗？想说哪一个？这个 slope， 这个 slope 讲出来。哦，这个 slope 你要记住这个照片。You need to remember this picture. Yeah. Yes. That's right. So you have a surface. Okay, you look at that direction, and then look at the plane that contain this. Not containing this. Actually, because plane containing this line, 有无限个其实，你懂我什么意思？ But why is this this flat one? I mean, you need to 讲解释哦这个东西。我想一下。Okay, you need to do the graph that I do just now. Yeah. Okay, either you get this normal vector or you get the other vector that together span this line. And then, 你 graphing 也不可以乱乱做，其实你的 graphing 不可以乱乱做，因为 graphing is depending on your basis，所以你的 basis 其实要选原本的那个3个 standard basis，你才可以做出我讲的。如果你选不一样的 basis 的话， then 你可能会做出不一样的3个 orthogonal。你一定要选这3个，才做得出我要的那3个。Okay, you need to choose the standard basis to do graphing. Okay, well, so if you get after you get this plane, what do? After you get this plane, your plane can intersect a surface. After this intersection, you will get a curve. Okay, after getting this curve, you can talk about the tangent line. And then the gradient of this tangent line is the directional derivative. So, well, I mean, yeah.
Well, so this directional derivative is from where to where? Is from R2 to R. So 它只是一个号码罢了。
它只是个号码，所以你要 interpret 这个号码是什么。Okay, how do you interpret? This is the gradient for the curve that you obtain from this surface through intersection. OK， 我觉得我有一个比较更好的方式去找这个 plane。Okay, because I know that this unit vector is coming from is it coming from? Yeah, coming from origin. Okay, so how to find the other vector that span this plane? You simply take the 0, 0, 1. Okay. Then you will span this plane here.
So 这个 plane 你其实要怎么想会比较好？这个 plane 其实就是
跟你的桌子一样，所以你全部人可以看你的桌子，把中间想成是 origin。OK， 把中间想成 origin， 然后 U 就是不同的方向。So how to get this plane here? You simply look at the what plane is that? ZX plane. Okay, you can turn the ZX plane around. Turn the ZX plane until the U direction. Okay, then this is the plane that contains U that we want. Does that make sense? 你可以这样转，可以这样，你可以这样转。OK，啊，说什么 ？KRN 到 N， 对，没有错 ，KRN 到 N 呀。If you consider higher dimension, you can go from RN to N.
Right, go R into R, yes. That's right. Good. 这个是他们之间的关系。OK, I think 我们讲完这个，我们可以 break 一下。这个讲完，我们可以 break 一下。OK, so 这个 gradient 有什么用？有什么个用处？
但是 gradient 有什么用处 ？Well, I mean, this is the some definition. But we can see the rate of change using this gradient here. So what it says, the function increase most rapidly at p in the direction of the gradient with rate of modulus of delta p, f and p.
OK, 我们来算一算他在讲什么。这个应该是一个 proposition 来的。So let's put it. Okay, let's verify this. Okay, let's verify this. 这句话什么意思哈？So if you look at your surface,
The function here is the function from two variables to one. So 它一直在说这个 surface， 说它说这个 surface 的改变不一定是 increase 啊，可能 decrease depend on 你的加减。So increase most rapidly at 一个 point P， 但是 point 上面有很多个 direction 嘛，哪一个 direction？ 他说 in the direction of the gradient。gradient 会 define 一个 direction 嘛？因为 gradient 是一个 vector， 因为它有方向。And then with rate of 这个 rate 的意思是什么？就是 one variable 有 rate 吗 ？one variable 的 rate 是什么
dy dx 哦，yeah，in 下面呢是 dy dx，在上面呢就是 directional derivative。在 two variable 的是 directional derivative，one variable 就是 dy dx 嘛。Okay, so let's compute the rate. Okay, so the rate here refer to so the rate here actually refer to the directional derivative. OK， 这个就是它的 rate， 对吗？是它的 rate 吗？
刚才我们是这样形容 du 嘛 ，dufb。我们有一个方向 ，we have a direction，and then that direction have a plane containing it，and then we look at the changes of that intersection。它改变的那个 slope， 那就是这个 dufb。
But UFP 怎么算啊？UFP equals to what? Delta F P dot with U。做 product 有一个 formula 哎，有人记得吗？啊 ？Norm of FP times norm of U times cosine theta。
然后这个题目讲什么？这个号码最大的时候 ，most rapidly， 什么时候这个号码最大？滴答要什么？滴答这个滴答是什么？这滴答 refer to 什么？你知道吗 ？The angle between the two vector here. Okay, delta f and u. 所以这个号码什么时候最大 ？Cos theta range from where to where? 1 to -1. So where's the maximum for cos theta? 1.
Okay, so you need to make sure what?
This 2 theta is angle what? Wait, how do you get 1? 0. So meaning this direction and your gradient vector have to align. There's no difference. Only then you will get the highest number here. I mean the largest number. So meaning you need to take your direction equal to the gradient. Only you will get maximize this number here. But what is u?
U we take as unit vector. So meaning what? This will be equals to del FP of cos theta and the should we say gradient? I don't want to say gradient. The directional derivative x maximum when cos theta is equal to 1, which is that equals to 0. Okay, and also, so this implies that u and delta fp should be in the same direction. And what's the maximum rate of change here? So the maximum of rate of change is just the length of your gradient vector. And so this is the part that I said that
I don't want the length from the unit vector to affect my direction derivative. 对吗？它没有理由来影响我的改变，我只是想看方向罢了。它的改变一定是要从 f 本身自己来的。OK, only depend on f。如果你想想看哦，把不一样的 u 放进来啊，它就会影响我去解释这个 f 的 chain of rate of change， 对吗？因为我要乘它的嘛，我要乘它的长度诶，这个 formula， 对不对？我不要让这个 direction 来影响我的 derivative， 我不要让它影响，怎样不让它影响呢？就让它变成1了，因为乘1没有改变嘛，乘2就变多少？乘 0.5 就变少。OK 了，明白了 ？OK, so that's why we pick our direction vector as a unit vector. because I don't want it to affect my directional derivative. 不要让它影响。我 directional derivative 应该只 depend on that， 跟我的点，跟我要拿。问题吗 ？Any question？ 有问题吗？我发有问题吗？等一下，呀，没问题，我们可以停在这边先，下次我们再讨论其他的。Okay, if you have no question, you can take a break now, 11 until 23, but you can come and collect your exam paper, then your cheat sheet. What you do is you take a photo, okay? Because you need to return me the paper. Okay, you can take a photo. Okay? And don't write anything on them. Okay. Okay. You can either take a break or you come and collect. Yeah. 还在一起，水继续。很波哎，那个很波的，没有，它有2张，改掉。等一下，我们讨论，不要紧张，不要紧张，等一下我们讨论，讨论完再搞多。先把问题收着，看下文的。好。我的一个。
会到几点啊？忘记了。
23 ，OK。
谢谢啊。
可以拿回去，可以拿回去啊，你可以拿回去你的，这样可以把你们机器拿回去收藏，如果你们 Okay, so let's go through the solution together and then see if I add out your mark, any mistake in adding out your marks. And I briefly comment which part you can actually do faster, because a lot of you say that not enough time. So let me argue my point. Okay, some of my point. Okay, so our first question was true or false. Actually, I mean, even if you guess true or false, right, I'll still give you some marks. But sadly, some of you just put blank. Okay, not sure why, but you put blank. Maybe too many words, is it? 太多字了吧，很多读的嘛。Okay, so I mean, one skill that you need to learn from mathematics 很不好意思是阅读，其实不是算，算不是数学的精髓，其实读才是数学的精髓。Yeah, obviously, if you're from high school, you think that it's just computation, but university maths is not about computation. Okay, it's about reading. Yeah. Okay, so for first one, I mean, well, if you look at 4 of these, right, 3 of these is what we discussed in class 1 to 3. Again, 4 is one that I come up randomly. So 1 to 3 actually come out in class, and quite good that actually few of you have the same exact solution as mine, because some of it already appeared in the lecture notes. And so, for example, what part 1, all the terms of a sequence get arbitrarily close to L if and only if infinitely many terms of A and R equals to Y. So if you remember, I draw in the class, there's an EX function, right? The EX function that I talked about when I talk about this proposition here. So what this statement trying to say? If the limit is L, doesn't necessarily that there is an infinitely many point equals to that limit. So the answer is false. Okay, why is it false? Because if you look at the sequence 1 over n, and this limit is 0, but none of it is equal to 0. None of the terms is 0. No need to talk about infinity. None of them is 0. But still, all the terms will get arbitrarily close to 0. Okay. How about 2? If the limit of the function does not exist, then if you restrict to the natural number point, also does not exist. Actually, this is the question asked by in the class. Asked by you, right, last time. 不确定，我确定。我确定，还有一个人也确定。你问的，因为这个 example 不是你自己给的呗，你不问忘记个题目，应该也要记得这个 example。Sin 2x. So this f value vary between -1 and 1. Okay, periodically. So if you take limit to x to infinity, it doesn't converge. But if you look at integer point, which integer point? Look at the multiple of 2 pi, then it's just 0 all the way. Don't converge. Okay, can remember this picture? How to remember this picture? Draw it out. So you have a sign. Okay, so where's the integer point? It is all this point, all these top point here. 画到有点丑，重新画一下。Okay, so where's the integer point or the maximum point here? Integer natural point exists, but function limit of function doesn't exist. Why is this? Because at the natural point it's just a 0 function, so it converges. C C 我故意写长长的。What is this statement here? 这是我们在班上 proof 过的东西。Limit of n to infinity of an is 0 implies that limit of an is 0. 那就这句话，这个东西我们 proof 过。We use squeeze theorem. Don't use squeeze theorem. So this is the only true statement inside this false statement. 4 says what? Since the series is meant to add up infinitely real numbers together, it must be divergent.
这题目你知道我在讲什么吗？把5000个号码加起来，是不是应该要改回去？你觉得是否 ？OK，已经有一点复杂了。你知道还有更简单的吗？啊？然后还有更简单的，把全部连加在一起就好了。Infinite real number 吗？零是 real number 吗？对，我 add out infinitely 零起来啊，就是零啊。对，其实有2个人写这个答案，好像至少有2个，我记得。你有写啊？川渝有写。对，因为我没有 specify 什么 real number 啊，任意的。零是一个 real number。看一下我写什么啊？我用 alternate harmonic theory 的，我也是用这个。就你跟我讲。哎，没有啊，我改了前面几张，我吓到我1跟2全部跟我答案一样，3是已经是一定要排名，班上是这样做，都是这样做，所以我吓到我，到底是我答案有没有泄露出去？1、2、3全部跟我一样，因为通常 counter example 大家不会想到一样，会想自己，但是I mean 另外一个证明就是说有听课或者有看我的 note 啊，另外一个说法。OK OK 啊，有问题吗 ？True false question，呀，来，对，说说看。OK，sorry，可能我这边确实有一个，就是有一点不太 precise，但是我其实这里也要表达就是那个 limit 嘛，就是那个整个东西，就是当你 n 取到后面的时候，它会 arbitrary close 不了，所以那个 n 去后面我是把它包在 arbitrary close 的。
如果我是如果按照
OK，等一下你来找我看，你来找我看，这样。但是我觉得你那个理解不成立嘛，因为就这句话肯定就，我知道你按这个题目理解，就是那个题目那样子理解没有意义，我是说。OK，我明白。就是说，如果你是说一个一个去看的话，我觉得就没有意义这个题，因为什么叫做一个点去 arbitrary close 去一个点，怎么没有这个可能性呢？给我2个点，它一定有一个距离，明白吗？我承认这边有一点点那个问题，小问题，但是它不应该被那样子理解，因为那样子理解的话没有意义。每2个点肯定是有距离，但是你写什么，等下我们可以讨论 ，OK 吗？听明白吗？OK 啊，没有意义啊。如果一个一个 term 这样去对比，不会靠近的，怎么会靠近？我跟你肯定有距离，每2个点不一样的肯定有距离，没有意义这样讨论。你是这个意思对不对？是这个意思吗？啊，等于是一个空的啊。
对哦，对一个，因为要
哦，你是那样子理解的。OK，I mean let me think 啊，我想一下啊，我的不要哦，对哦，I mean 因为这个 arbitrary 的问题，I mean 这个 arbitrary 没有定义好来，
那个哦，
也是 all 的问题，也是这个 arbitrary 的问题，因为这个 arbitrary 其实有包含了那个 n 大于。可以，你可以拿你的答案来看一下，你也是有问题啊。OK，那你们2个等一下过来讨论一下。OK，把我承认这个 wording 有一点点问题，就是问题。把我的意思是那一个，就是 limit 的意思。其实我一开始是 a sequence 跟 arbitrary close。
其实我一开始是对啊，我不应该要听我的 vector 讲的 vector 讲的东西，就是有一个老师就不应该要听他讲。算了，我下次学会了，sorry 有时候我应该要坚持一下。sorry，我没有想清楚这个，但是就等一下我们可以讨论一下你的答案，看一下怎样 make sense 吧。All right，question two。actually question two 是最简单的一题耶，很多人全部 miss 掉，看到 proof 就跑了。对啊，就两行的。Directional 也有啊，看到这题就跑啊，全部人。So I mean, prove that these two formulations of sequence is equivalent. So 你要 prove 什么 ？Definition one imply definition two, definition two imply definition one. Okay, so how to imply? So definition one imply definition two says what? You start with a1, a2 up to an until n infinity. Then how to define a function? So to define a function, what do you need to do? You tell me where I send the domain to. 我把 e 送去哪里 So this function from where to where? From natural number to real number. So you tell me where 1 sends to, 2 sends to, 3 sends to, 4 sends to, 5 sends to. Where should that send to? Actually there's a natural order of integer already. A1, A2, A3. So you just send Fn to An. Okay. 明白我讲什么吗？大家川语有问题吗？ OK， 你不知道有什么问题，是因为你不知道什么叫做 function， 是不是？什么叫做 function？ What does it mean by function? You give me a element in the domain, tell me where should the image be. 一应该要去哪里？二应该要去哪里？三应该要去哪里？ You need to define. But I say that I claim that there's a natural way to define this function. What's the natural way? Just send 1 to A1, 2 to A2, 3 to A3. And then this will settle all the n. Correct or not? Because I got a n to a. I don't want to say a infinity, but all the n in natural number. Okay, so for all the n, I just send it to a n. So this define a function. Okay, and then if you have a function, okay, I know where I send 1 to, I know where I send 2 to. Can you define the sequence or not? Can you define a sequence? How to define a sequence? What sequence have to be? Just a definite order, infinite number of definite order. So can you find infinite number here or not? You just take the image of the function. Okay, you just take the image of the function. So an is equal to fn. OK。其实这一题我在班上花了差不多半个钟在那边讨论所以意思说如果没有做得出，就是你没有在听我讲那半个钟，而且你没有问我，这个是重点，你没有问我。其实你在我班上没有读书，没有听我讲啊，我是不会抓你的。但是你又没有读书，你又不会，我就会抓你啊。OK， 你可以用你的方法，但是你要用你的方法读到会，那读不会我就抓你了。所以一开始你们要怎样读书在我班，我是不会抓你的。等你成绩烂，我就开始抓你了。OK， 证明你在班上没有听，然后你又不会。OK 了，这是我会很生气的一个点。OK， 可以明白吗？可以明白这个答案吗？现在至少就要明白了。OK， 这个东西在 lecture note 里面也是有的。OK， 所以我如果在班上花什么很长时间跟你们讨论啊，那个东西 probably 就会出现在考试里面，因为我们要考班上讲的东西，班上衍生出来的事情。OK， 说这一题啊，这一题我有很多话要讲。你跟我讲话很长时间啊。这题就是一个如果用 example 学习就会出的问题。你一看到 alternating series 啊，就想用 alternating series test。但问题是你解决不了这个题目。这题目问什么？这题目问你 absolutely convergent。你说 convergent 的定义是什么？定义什么？怎么说一个东西是 absolutely convergent？ If what? If the sum of absolute an is convergent。所以你要看的是这个 alternating 嘛？不是，你要看的是他们的 absolute sum。你明白吗？所以很多人呢、看到这题啊，就想把 alternating series 用进去吧，用处没有用。为什么？你不是在解决这个题目，你在解决的是这个 series converge 吧？有没有？我又不是问你这个问题。所以这个就是用 example 学习的坏处啊。你看到这个 series，你就想用一个相关的 test，但我又不是问你这个问题。现在我问你是它的 absolute an converge 吗 ？OK， 如果 converge 的话，它就 absolute convergent；如果不 converge 呢，你还可以做什么事情？你就要算它原本这个 alternating series converge 哦，对不对？如果 converge 的话怎么办？它就 conditionally converge 哦。如果它不 converge 呢，diverge 哦。OK 了呢？呀，这个逻辑你要搞清楚哎，也不是一看到 series 就 test，series 就 test，series 就 test，不知道你在 test 什么东西。OK 吗？读清楚题目先，看清楚题目要什么。因为你这样子乱用啊，alternate series test 啊，我问你啊，要 check 几个条件？2个条件哦。你 test 不出来还 diverge，怎么办？你看你时间全部花在这边了，浪费时间。你应该直接就要去看这个 absolute of an 是什么东西。如果那边 convert 就解决了这题目，不 convert 才要继续。OK，so right， 我们看一题一题看。所以这个 A B C D actually 考你们一项东西就是怎样看 pattern。其实你们都会看 pattern actually， 你们都有拿到这个 pattern 分。所以如果你看得出这个 pattern， 我就给你分了。其实 OK， 看完这个 pattern 过后，你就要去看了 absolute of x and you converge 嘛。OK，in first case actually it converts by comparison to P series，where P 是等于 3。OK， 说因为什么？因为你拿到的 term 是 n over n plus 1 over 1 over n cube。然后第一题是用 P series， 好像大部分都是用 P series 做这题。OK，good。第二个呢？第二个你会看到，如果你做 absolute Sn sum 的话 ，actually 它是 divergent。好像你们有用 limit comparison test 啊之类的 ，which is quite good。Then 你要 show that whether the alternating series converge or not. So in this case here, you really use alternating series. Okay, you check two things: whether it decrease or whether it take the limit of the an converge to zero. Actually 这 part 没有什么问题，大家都是这样做。上面一 part 会不一样。Okay, what do you do? Some of you just use algebraic inequality 哦，就是上面小于下面，然后你就 prove that it is true for all n。or 你在 for what we do in class, we also introduce that you can treat it as a function. You prove in assignment, right? If this function is decreasing, then the corresponding sequence also decreasing. Okay, you can use these two ways. So B is conditionally convergent. C I think C 很多人做得错，就是 ratio test. Okay, because ratio test is very strong. Ratio test doesn't tell you convergent only, it tells you absolutely. D is conditionally convergent also. Okay, so B and D actually has the same flavor. Okay, B and D same flavor. 如果你说我要 decrease 这个题型的话，我觉得 B or D 可能我选一个，可能把一个丢掉，因为反正他们是做一样的。 如果真的我要减少题的话，应该 B 和 D 我会去掉的。但是我一般我也是想说，就是but anyway 不要再想了。So question 4 question 4 about finding interval of convergence and radius of convergence， 好像感觉很多人都忘记了这题讲做，可是我忘记了。So what is the how to get the interval of convergence and radius convergence here? Basically, you use ratio test. Okay, you have to make sure that the limit is less than 1. So where the interval come from? Where the radius come from? Because this power series has an x there. Okay, so this is where the interval and the radius come from. So there's a condition on this x minus 2 here, which is less than 1. Where the less than 1 come from? You use a ratio test such that the series converge. Okay, such that the series converge. And then this is the exact question that we do. You need to check the endpoint. Remember in the class we discussed. Check the interval radius of convergence. You need to check endpoint, right? The radius is what you get from the ratio test, and the interval you need to check endpoint. Okay. In this case here, the endpoint is easy to check. One of them is harmonic series. The other one is after looping. Okay. Yeah. 其实你考试忘记不用紧，但是你下次要记得为什么我会忘记这些东西？你的这些知识要怎么记在脑？你下一次就要努力。OK 了，为什么会忘记这次？为什么没有读到？为什么 miss 掉？你下一次就要全部把它抓回来，全部知识点。OK 了，呀，不是说你这次失败就是失败了，你要用这次的失败去 motivate 你下次怎么去应对。OK， 你不能够永远失败的，我告诉你。OK， question 5。I thought question 5 is quite computational， 但是好像很多人就看到题目很长又乱了，是不是 ？Fourier series coefficient 嘛 ，Fourier coefficient 嘛，对不对？就3个东西嘛，你要记得 AN、A0跟 BN， 拿进去算吧哦。呀，不要看到题目长就乱了，开始乱了，去找那些重点的字眼。For example part A what is the important here? Fourier coefficient. B 呢 Fourier series. And then C odd or even. D you need to what do you do? How should fx define at this point here? Okay, D is a bit tricky. I agree. 这个题目是我自己出的。Okay, so A, B, C, what do you do? A after you find AN. Bn A0, what do? You put them together to form Fourier series in B. Okay, you put them together. 要 go through 怎么算嘛？其实最重要是这个 L， 你不要算错就可以了。How to get this L？ 不要，可能有些人放10，好像没有你们班好像没有做这件事情。一的你有做啊？谢谢你们的诚实。OK。很容易犯的错的，这个容易犯错，就是说其实这个 L 不是它的 period， 是它 period 一半。OK， 它 period 一半。在班上我们有2个这个东西，是它 period 的一半。OK，and then 算就是很 normal 的算法。Fourier series 就把它配在一起哦。最重要可能你要记得要除2一下。C。Okay, C. I comment that whether this Fourier series is odd or even after removing the constant coefficient. So after removing the constant coefficient, you should consider you only left with sine function. So sine is 假设如果你是 B 算错然后你用 C 来做 B 你肯定跟我答案不一样。所以如果你是 comment 对，我可以给你分。我忘记有没有人做这件事情，你懂我什么意思吗？因为 C 的答案是 depend on B， 所以如果你 B 是错的，可能 B 算到 cos instead of sin，then 你就会 comment 说这个是 even，then 你就会拿分，你也有分。我们叫做 error carry forward， 就是因为它是 based on 你前面算的。OK， 虽然你前面算 ，OK 吗？因为不可能嘛，你前面算错，肯定后面也是错的，一定跟着的。但是我是 C， 我是要考你说你会看得懂你 B 算的东西。 Okay, D yeah, D is the convergence Fourier theorem. Convergence Fourier theorem. Yeah. So D 在问什么哈？If you observe this function here，在0点，在5跟减5点啊，我们是没有 point 的，没有点的。So how should you draw this? Let's quickly draw it. So 我有0，我有5，我有减5。Okay. 0 from 0 to 5 we have 3. So without point here, this is 3, and then there's 0. 用另外一个颜色，用这个。OK， 所以那边没有点。但是 what do I say? Can you add point to these 3 points like that? The Fourier series will convert to fx 在那些点上。懂没什么 ？So can I define? So how should I define fx on this point? 就是说这些点我的 f 要取什么 value? Such that Fourier series will converge to fx at this point. 什么意思？就是在这些点上面，它们要 equal。所以问的问题是什么？问的问题应该是 What does the value of Fourier series take at this point? 但是这些点是什么点呢？ Is the point of this continuity. 但是 convergence of Fourier theorem 告诉你什么 ？At the point of this continuity, f of x 是什么 ？Half of the limit from the left and from the right. So you look at the point of this continuity. What's the half of the limit from the left plus the limit from the right? 0 plus 3 is 3. 3 divided by 2 is 7. 所以你要把这个1/2的点加进去。OK， 所以你要把这个1/2点加进去。你看下 Fourier series 怎么画？还记得在班上我讲话吗？这样，I mean， 这样子，然后上去这样。但是它切的这个点是在哪里 ？Where does it converge to? Half of the limit from the left of the original function and from the right. Sum of them. Okay, half of the sum of the limit from the left. Okay, so your fx have to be like this. Okay, you have to look like this. So you could imagine that your Fourier series is like this. OK， 这个图我一直在班上画哦，印象吗？我还讨论说这个可以切过来一点，还可以切过去一点嘛，是不是？但是如果切过来一点，切过去一点，它就不太 converge 了，有些 part， 它一定要避免掉一些部分，懂什么意思吗？哦、let's say if I need to cut lower then 这个 part 就不会 converge 了。OK， 所以如果要两边都要很接近我们有的东西的话，它一定要从中间切去，因为它要越来越直，越来越直，越来越直。But impossible to get the straight line， 只是越来越直。OK，so part D 就是在 test 你的convergence of Fourier theorem， 所以你一定要明白这个概念。如果你不明白，你肯定是听不懂我讲什么，但是你就是要明白它这个东西，一定要明白这个概念。OK， 呀，你听不明白我讲什么，你一定要回去再看一次。OK，last， last 的话 ，I guess 画 I think 你们都会画，其实算就会有一点粗心哦，有些人，然后可能有些人剪错，然后有些人拿错 angle，yeah，something like that， 把画全部都会画。I think quite simple， 就是 circle 跟这个。Yeah， 讲一下。Yeah， I think that's all， 差不多是这样。啊，有问题吗？有问题吗？有什么？你觉得你对还是你可以问的？So highest score in this class is 98. So it is 2 girls. 哇，没有女生在我班拿高分，最高分的。 这班恩慈跟那个子莹，所以你们是非常好的例子。你知道啊，我上学 topology 的时候啊，全班是男的，然后我学生有一个女的进来，她讲啊，你的课就是这样难，然后没有一个女生呢、我觉得这个人看不起自己的性别，看不起女生，是不是？啊，我这个班其实最强的是女生的这个班，top three 都是女生，我有5个85分以上，但是就 top three 是女生。哎，你们怎么学习啊？可以分享一下吗？分享给其他人一下，你怎么学习？嗯，子这个课啦，不是其他课，就这门课就好。看到罢了，是不是？很有用啊，有用不？所以一定要看懂我的弄。你会花很长时间看我弄，不会呗？不会啊，多长？要去算，前一天才看，真的啊，你平时都没有看哦？没有啦，我是说你平时读这门课的时候是怎么读的？你有做 tutorial 吗？你有做 tutorial，课本 tutorial。OK，你做什么 tutorial？哦，last chapter 那些题目。OK OK，好，还有吗？Other than that，还有吗？有什么特别准备吗？这个课没有啦。子英呢？还有嘞？Lecture notes 呢？有看？OK。tutorial question 呢？课本有没有做？稍微做一点啊。有啊，你有来问我啊，有时候。OK，可以参考一下大家怎样读书啊。我 lecture 都非常重要，你一定要看懂它。你看不懂，你一定要来问我。我看不懂的，你要来问。你不可以是 let it go，let it go。我一定是抓住那个东西来问你，你明白吗？然后我会反来反去问，一模一样东西。其实你看答案啊，全部是你看过的东西。但是你要想一下，为什么当下你读那个题目会读不懂？这个是你要做的事情，对吗？呀，读懂题目很重要。OK，这是我考试的特征来的，就是它答案一定是你看过的，只是它怎么拼起来，你就要想。OK，所以我是不会一直做 example 给你看的，因为我是不会出我做过的东西，你懂吗？所以你不用这样指望我，我是不会错的。我考过你这个一次，我下次就考你另外一个东西了，但是它的概念是一样的，你懂什么意思？所以我跟你讲过啊，我以前大学啊，他给我们做 pass 啊，10年啊，10年没有 repeat 过了，他题型没有 repeat 过，都好像全新的，每次看到就是这个意思。虽然是全新，但是他用的东西就是看过的东西，只是说你知道要用哪一个吗？只是说你明白吗？啊，我考试是这样呀，我一定 make sure 你没有看过，但是一定 make sure 是你知道，I mean 你学过的东西，OK 吗？所以在我班我教 example 没有什么用，因为你用 example 学的那些什么技巧啊，你是不会在新 example 看到的，只有那个 example 的核心概念你会一直看到吧，就那个核心的 concept 你会一直看到它，明白吗？因为你看啊，比如说这种 series 题啊，我可以换题目的，我可以换成 converge 罢了，不要 conditionally converge 吧，然后你就可以 start with 你的 alternating series test，你明白吗？我可以用一个 series 反着问、正着问、乱乱问的，明白吗？所以是那个概念你全部要搞清楚。Obviously，搞清楚概念是需要 example，但是我是说你不可以用 example 去
缺席吧。因为一个坏处就是我会看到你看到这一题就直接丢 other AC 进去嘛，然后你丢到最后你也不知道你在做什么，其实你自己读一下你自己答，你写到最后啊，你拎不回 conditionally convert 或者 actually conversion，因为你就是不是在解我叫你解的题，在解你自己想象的题。所以这个就是一个 example 的坏处哦，你会有一个固定的思路在里面，但那个又不是人家要走的路，我要走的是另外一条路，懂吗？会被 trap， 你 study by example 会是容易被 trap 进这种脑回路。啊，这 example 是 good， 是 good 是好，但是你不可以被 trap 进这个思维里面，因为很容易，真的很容易被 trap 进去。OK 吗？我证明给你看了哦，我用考试证明给你看。You have to go through this process， 你们一定要 go through 这个 process， 因为不然你会不明白我在讲什么。等你 go through 一次啊，你就知道我要表达什么东西。所以你一定要错一次再玩。OK， 所以这样子的话，我们会让全班过的是 OK， 我会 scale 最低分就是在最低好像是22，有4个人很危险哦。OK， 22分了，可以念你们名字吗？我看一下，我没有讲你们分数啊，但是你们很危险的。小杨啊，洪杰没有在，金盛哦，还有一个我记得，维权 ，OK， 说如果你们 final 还是22是有点难过，OK， 所以 final 一定要拉上，是吧？虽然我这次来就把你们拉成 pass， 但是如果 final 是20多的话是很难过的，20、30都很难过，你一定要30、40以上，OK 吗？真的要努力一下，不懂的一定要千万要搞懂它，不可以就这样过，不能过的，过不去的，OK， 一定要搞懂，可以吗？呀、OK， 有其他问题吗？还有个问题，分数的问题啊，OK， 等一下，其他嘞还有吗？我 scale 了过后，我会让你们知道，scale 成怎样。OK， 所以现在大。